Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. Today, we'll be looking at the integration by the substitution of indefinite integrals. This is part 17, and I encourage you to check out all the other parts prior to this part. We are still working on the integration series, so I encourage you once again to subscribe so that you don't miss out on any of our future upload. Diving into today's business. The integration by substitution is the process of transforming a complex integral into a simplified one, which is actually the purpose of this channel, Numbers Simplified. Let's take a quick look at the steps involved in the implementation of the substitution method when integrating. 1. Identify a suitable substitution U that simplifies the integral and with the derivative similar to that of any other term inside the integral. 2. Differentiate the new variable with respect to the old variable and move on to make dx to be the subject of the formula. 3. Rewrite the integral completely in terms of the new variable u, including the limits in definite integrals. But we won't need to worry about this step in this video because we are dealing with indefinite integrals. But make sure you don't miss out on our next upload, as it would be for the definite integrals. Step 4. Integrate the resulting or the new integral with respect to the new variable. Let's take a look at example 1 now. Find the integral given the substitution. So we have the integral of x times the square root of 1 minus 2x squared dx. In this case, we are given the substitution u is equal to 1 minus 2x squared. So we won't have to worry about identifying the suitable substitution. The solution. Since we are given u to be equal to 1 minus 2x squared, we move on to differentiate the u with respect to the old variable x so that we get du over dx is equal to minus 4x. And with that, we would need to make dx be the subject of the formula so that we get du over minus 4x being our dx. We then move on to substitute the dx and the u in the integral. Upon doing so, we are going to have the integral of x times the square root of u times du over minus 4x. Now, I would like you to take note of something. That minus 4x carries an x that's going to cancel out with the x that was in the integral before. So that's why we need to identify a suitable substitution such that when we differentiate it, we are able to cancel out with other terms, because in that way, we simplify our problem. Now, simplifying what we have over here, we are going to have the integral of minus 1 over 4 u to the power half du. We've just applied the laws of indices here. We know that the square root of u is the same as having u to the power half. And of course, the minus 4 gave us the fraction minus 1 over 4. So in this case, we are going to integrate so that we get minus 1 over 4 times 2 over 3 times u to the power 3 over 2 plus c. And recall, our u was equal to 1 minus 2x squared. So we substitute for u, in this case, expressing the u in terms of x. So in doing that, we are going to have our final answer as minus 1 over 6 times 1 minus 2x squared, all raised to the power 2 over 3 plus c. That will be our final answer. Let's take a look at example 2. Find the integral using a suitable substitution for the integral of 5x times 2x squared plus 1, all raised to the power 5 dx. This time around, we were not given the substitution, so we have to identify the substitution. So in the solution, we can observe that the 2x squared plus 1 can be a potential substitution. Why? Because once we differentiate that, we can get something that can cancel out with the x. Because we have 2x squared, if we differentiate that, we can have something with x terms that can cancel out with that x, and in the process simplifying our problem. Great then. So we select u to be 2x squared plus 1 now. Then we differentiate du dx, we get 4x. Then the next thing would be to make dx the subject of the formula. So dx is equal to du over 4x. Then substituting for the dx and the u in the integral, we are going to have the integral of 5x times u to the power 5 du over 4x. So that 4x carries an x that will cancel out with the x next to the 5. So once that happens, simplifying, we're going to have 5 over 4, since this is a constant, times the integral of u to the power 5 du. Simplify further, we are going to have 5 over 4 times 1 over 6 times u to the 6 plus c. Then we would have 5 over 24 u to the 6 plus c. And recall, our u was 2x squared plus 1. Substituting for the 2x plus 1 into the previous equation or previous solution, we are going to have 5 over 24 times 2x squared plus 1 to the power 6 plus c as our final answer. Let's look at the final example for the section. Find the integral using a suitable substitution. The integral of 3x times e to the power minus x squared minus 2 dx. So for the solution, we can see from the integral here that we can actually select minus x squared minus 2, because once we differentiate that, we are going to have x terms that can cancel out with the x that is next to the 3. So that might be actually the best substitution to make. So selecting u is equal to minus x squared minus 2, we find the du dx, we get minus 2x. Then we move on to make dx the subject of the formula so that we have du over minus 2x. Then we substitute for the dx and the u so that we get the integral of 3x times e to the u du over minus 2x. Now, the x's will cancel out so that we have minus 3 over 2 as the constant taken out of the integral of the integral of e to the u du. And we know how to find the integration of the exponent from our exponential video, and I encourage you to check it out. So in this case, we are going to have a minus 3 over 2 e to the u plus c. And once again, recall, our u was minus x squared minus 2. So expressing u in terms of x, we are going to have our final solution as minus 3 over 2 times e to the minus x squared minus 2 plus c is our final answer. If you've made it this far, congratulations. I won't be leaving you with the task since we are going to continue with this. Make sure you subscribe so that you don't miss out on any of our future uploads. In the next section, we are going to cover the integration by substitution of definite integrals. Thank you so much for watching Numbers Simplified. God loves you.